Hello, ICS scholars. I am Mr. Sutton. I am a geometry teacher at Heron High School. And today we are going to be talking about the angle addition postulate and angle pairs. So I want you to make sure that you have your notes in front of you and something to write with, and I want you to go ahead and pause this video and write down this definition for the angle addition postulate that you see here. So now what this says is the angle addition postulate states that if point D is in the interior of ABC, then angle ABD, this 60-degree angle, plus angle CBD, this 40-degree angle, equals angle ABC, this whole thing. Now I highlighted this to help us see everything. So ABD is this blue angle, CBD is this red angle, and ABC is made up of these purple sides. So that's the whole thing, the 60 degree and the 40 degree, right? And we see the same thing in the equation down here, that angle ABD, we know that's 60 degrees, right? Angle CBD, we know that's 40 degrees. And angle ABC, this whole thing, we can see is 60 degrees plus 40 degrees. It is from here all the way to here, so that would be 100 degrees. And this works because we know that D is in the interior of ABC. So since D is in this spot right here, if you were to extend these lines out, you can see that D falls in between those. The exterior would be like if D was out here, so that wouldn't work the same. So this works because D is in the interior of this angle. So here's an example of looking at the same kind of problem, but now we're looking at it algebraically. So we have the measure of angle ABD. We know that this whole thing is 100 degrees. But now, so we're given that, so let's say now we want to find x. So we can do that algebraically using the angle addition postulate because we know each of these angles individually as algebraic expressions. So we can say angle ABC, the measure of angle ABC, plus the measure of angle CBD. So this angle right here, measure of angle ABC, plus the measure of this angle right here, measure of angle CBD, equals 100 degrees. So now we can convert that to our algebraic expressions. The measure of angle ABC is 4x plus 2. And then we want to say plus, I'm going to go ahead and put this in parentheses, plus the measure of angle CBD is 3x minus 7, and that equals 100. Now I have an algebraic expression that I can solve for x, so nothing to distribute. I can combine like terms. 4x plus 3x is 7x, and then 2 minus 7 would be negative 5, equals 100. Add 5 to both sides. 7x equals 105. Divide both sides by 7. X equals 105 divided by 7. Let's see, so that would be 15. So we have some new definitions that go along with when we're talking about angles being added together. So again, make sure you are writing this down. Make sure you're getting these definitions down. So complementary angles, these are, when we're adding angles together, complementary angles, they will add up to 90 degrees. So complementary angles, definition for that is two angles with, let's say, with a sum of 90 degrees. Supplementary angles are two angles with a sum of 180 degrees. These two things, I think, are easy to confuse with one another. So one trick I have learned to keep these straight in your head is C comes before S in the alphabet. So C for complementary, S for supplementary. C comes before S in the alphabet. And then 90 comes before 180 when you're counting. So that is one way that you can think about that. So C, associate that with 90. S, associate that with 180. Next definition, linear pairs. And notice I have linear pairs underneath supplementary angles. And the reason for that is because a linear pair is actually a type of supplementary angle. So what linear pairs are, those are supplementary angles that form a straight line. So you might be thinking, well, supplementary angles, they have a sum of 180 degrees, so wouldn't they form a straight line as well? The thing is, supplementary angles do not have to be attached to each other. They can be completely distinct angles that don't share any lines in common. Linear pairs do have to be attached to each other. So I drew a picture up here. So this example over here, we have this angle is 30 degrees, this angle is 150 degrees. That is supplementary. Those two angles are supplementary, but they are not linear pairs because they do not form a straight line at all. This example over here, we have a 30-degree angle, 150-degree angle. These are also supplementary, but they're also linear pairs because we have this straight line here on one side. So definitely draw yourself a picture like this so you can keep these things distinct in your mind. So if I say two angles are supplementary, they are not necessarily attached to each other. If I say they're linear pairs, then yes, they are attached and they have a straight line on one side. Now, what do we call angles when they are attached to each other? We call them adjacent angles. Adjacent angles are two angles that share a common side. So like this example up here, two angles that share a common side. And one thing I should probably mention also is complementary angles. Same as supplementary angles, complementary angles do not have to be adjacent. They can be two totally distinct angles that add up to 90 degrees. Again, adjacent angles are two angles that share a common side. And then vertical angles. Vertical angles are angles opposite each other on intersecting lines. So they do not share any common sides, but they do have that common point. So like if I have these two intersecting lines, we see that this angle is vertical to that angle. Okay, so make sure you have these definitions written down and we'll go through some examples with these. Now, the reason vertical angles are interesting, so let's think about, so I have angle ACB here and angle ECD here. These are vertical angles. The reason they're important to us, if I think about how these angles are linear pairs with this angle B CD right here, we can come to an interesting conclusion. So like if I think about how, so angle ACB is linear pairs with angle BCD, right? They form this straight line AD. So that means I know they're supplementary. So I know the measure of angle ACB plus the measure of angle BCD has to equal 180 because they form this straight line. And I can do the same thing with angle ECD and angle BCD. Those are also linear pairs. They form this straight line BE. So I can do that same thing. Measure of angle ECD, this angle right here, and plus the measure of angle BCD again, adds up to 180 degrees. So what we're getting to is these two angles are actually the same measure, right? So like if I were to take this first equation and subtract the measure of angle BCD on both sides, I would get the measure of angle ACD equals 180 minus measure of angle BCD. And I can do the same thing for the second equation. The measure of angle ECD equals 180 minus the measure of angle BCD. So these two angles equal the same thing. They both equal 180 minus BCD. So let's say we know this BCD is 100 degrees. Then that means we know that both of these, 180 minus 100, 180 minus 100 equals 80 degrees. So one thing that is very important to know about vertical angles is vertical angles are congruent. And if you remember, the congruent symbol is the equal sign with the squiggly on top. So, and that is always true. Vertical angles are congruent. The opposite angles on any intersection are congruent. So, like if I know this is 100 degrees, that means this has to be 80 because they're linear pairs. And these are vertical, so this has to be 80 as well. And that means this angle over here has to be 100 degrees because those are vertical. So really, if you have an intersection like this, once you know one angle, you're pretty much given the other three using linear pairs and vertical angles. So make sure you have this information down. This vertical angles are congruent is very important to a lot of the geometry we will be doing. Now I wanted to take a look at some examples that you'll see on Delta Math during the practice. So we're given that we have the line PQR, so we know that's a straight line. Use a protractor to measure PQS and RQS, also determine the sum of the two angle measurements. So we already used the protractor a little bit before, but now we're using it with linear pairs. So we want to grab this dot here in the center and line it up with Q. And then we want to put the 0 on one of the sides. And we want to do it in such a way that the common side that is shooting out is on the protractor. So I don't want to do it this way, right? Because that doesn't tell me what either of these angles are. We want to do it this way. That way I can zoom in here. And see that, so this angle goes from 0 to 151, and that is PQS, right? So I'm going to say the measure of PQS is 151. Now some protractors have 0 through 180 this way and 0 through 180 the other way, which is nice, but this one does not. So we're going to have to do a little bit of thinking to figure out what the measure from here to here is, right? Because it's not 180, it's not 151. It's actually the difference of those two things. So 180 minus 151 would be 29, right? Yeah. And so if we add those things together, we should get 180. And we can even see that, 0 to 180. So do we want to submit that? Yes. And that's good. That worked. So that's how you do that. And there's your explanation. So here we're on to angle terminology with equations, and I selected a complementary angle type problem. So it says angle A and angle B are complementary angles if the measure of angle A is 6x plus 1 degrees and the measure of angle B is 8x minus 23 degrees. Then find the measure of angle B. So we know they're complementary. We know that they add up to 90. So measure of angle A plus the measure of angle B, we know equals 90 degrees. So the measure of angle A we know is 6x plus 1. The measure of angle B we know is 8x minus 23. We know that that equals 90 degrees. So now we have an equation that we can solve for x. I'm going to go ahead and do that to save some time. So I got x equals 8. And we want to be careful here because it does not say find x. It says find the measure of angle B. So now we want to plug 8 back into what we have here. So the measure of angle B is 8 times 8 minus 23, which is 41 degrees. So I have it typed in here. Let's check that. Answer 41. And yes, that's correct. And here is the explanation. Supplementary angles is another type you might get. So it's very similar. We have two angles that are supplementary, and they give expressions for each. And then it says find the measure of angle A. And I'm not going to go through this one because it is very similar. The difference is instead of setting it equal to 90 degrees, you set it equal to 180 degrees. So I'm going to leave that one for you to try on your own. Here's one on vertical angles. So angle A and angle B are vertical angles. If the measure of angle A is 5x minus 3 and the measure of angle B is 4x plus 21, find the measure of angle A. So the key information here is that they're vertical angles, so we know they are equal to each other, like we talked about. So the measure of angle A has to equal the measure of angle B since they are vertical. So I know the measure of angle A is 5x minus 3. So I know that has to be equal to the measure of angle B, which is 4x plus 21. And then now I have this expression, which I can solve for x. And I'm going to do that right now to save time. So I got x equals 24. Once again, we're not trying to find x. Go back to the question. It says then find the measure of angle A. So I want to plug this 24 into 5x minus 3. So I'm going to go ahead and do that now. So I got 117. Let's go ahead and check that. 117. Submit answer. Yes, and that is correct. And then the last type we have here, this is also vertical angles, but notice the difference. It says then find the value of x. So here we are looking for the value of x. We don't need to do that extra step of plugging it back in and finding the measure of one of these angles. So don't get tricked by this. Make sure you read the instructions and ask yourself, am I looking for the value of x or am I looking for the measure of an angle? So I'm not going to go through this one because it is very similar to the previous one I went through. It just doesn't have that extra step of plugging it back in and finding the angle measure. So I hope this helped. If you have any questions, please go to office hours. Please write your questions down in your notes so that you can ask them when you get to class, so that you don't forget what questions you have. Otherwise, have a good day. And if you are my student, I will see you in class.